Hello and welcome to my channel. Today we shall take up an assignment problem when the given matrix is unbalanced. So that is, we are going to solve an unbalanced assignment problem. So first let us understand what is unbalanced assignment problem. So we usually see that the number of rows are equal to number of columns given in the assignment problem. So when the number of rows are equal to number of columns, we call such assignment problem as balanced assignment problem. But sometimes the number of rows may not be equal to the number of columns. Either the rows are less or the columns are less than the rows. So let us solve such a problem in this session. So solve the following assignment problem. They have given us the matrix. We can see here M stands for men and J stands for job. So we are having 4 jobs A, B, C and D. Men, we see that it is given row wise and there are only 3 men. The tasks assigned are 4, to be done are 4, but the men here are only 3. So here we can say that the number of rows are not equal to number of columns. Such situation we call as unbalanced assignment problem. So how do we solve such a problem? The first step here is to convert an unbalanced assignment problem into balanced assignment problem. So for this, we are going to add a dummy row or dummy column according to the problem given. So if the rows are less than the columns, then we are going to add a dummy row. And if the columns are less than the rows, we are going to add a dummy column. So in this case, we are having less rows as compared to the columns. So the jobs to be done are more than the men available. So we are going to add a dummy row and we will assign the cost as 0. So in that row, all the elements will be taken as 0. So here this matrix relates to the men and the job and we need to assign which job is to be done by which worker. Here the elements indicate the cost involved. So if men 1 is given job A, then the cost will be 7. Now when we add a dummy row, the cost element shall be taken as 0. If we add a column, dummy column, even in a dummy column we will have all the elements as 0. Okay, so let us proceed and see how to add this dummy row. So first thing we will do here is step 1, add a dummy row with 0 cost. So you can see that there are 4 jobs. Now to balance this, we have added a dummy row that is 4. All the other elements will remain same. Only the 4th row element will be assigned 0. Okay, so I will just write down all the elements as given in the problem, and for the 4th row we will take it as 0. So here in this row all the elements will be 0. Now this will be our matrix based upon which we will be assigning the task. Okay, so now we will follow our regular process, that is the first step now again will be row minimization. So now we will be minimizing, we will be taking the minimum element of each row and deducting it from other elements. So first row, the minimum element is 4. So we will deduct this 4 from each of the elements in the row. So here, now we will go for the row minimization. So for row 1, it is 4. So 7, so we can see it is 7. 7 minus 4 will give us 3. 5 minus 4 will give us 1. 8 minus 4 will give us 4. And 4 minus 4 will give us 0. Now come to the second row. The minimum element in the second row is again 4. Let us deduct this 4 from all the elements. 5 minus 4 will give us 1. 6 minus 4 will be 2. 7 minus 4 will be 3. 4 minus 4 will be 0. Now for the third row minimum element is 7. So 8 minus 7 is 1. 7 minus 7 will be 0. 9 minus 7 will be 2. 8 minus 7 will be 1. Now the last row is the minimum, all the elements are 0, hence the minimum element will be 0. Anything deducted with 0 will be 0. Okay, so this is our row minimization. Now the next step here is column minimization. So column minimization, we can reduce our work by one step here. So we can see here each column is having a 0. When there is a 0, it means that there will be no change in the elements of the matrix. So 3, 1, 1, 0. So 0 is the minimum element. So when we deduct 0 from any number, we are going to get the same number. So 3 minus 0 will be 3, 1 minus 0 will be 1, 1 minus 0 will be 1, 0 minus 0 will be 4. So this you can, just by seeing, we can look at this and we can conclude that the same is going to repeat here again. So 1, again coming to the second column, 0 is the minimum element. So 1 minus 0 will be 1, 2 minus 0 will be 2, 0 minus 0, 0 minus 0. Now coming to the third column, the minimum element again is 0. So the same values are going to repeat. Now last column is again the minimum element 0. So we shall take the same elements. So we can see that there is no change when we do it column wise. So we can just reduce this step and we can write row minimization and column minimization here. Now coming to the next step here will be assignment. Now we need to make the assignments as per the final matrix. So the final matrix here will be taken for assignment. So I will just write down the same elements here in a separate matrix so that we can easily differentiate here. 2, 3, 0, 1, 0, 2, 1, 0, 0, 0, 0. So let us not mix this step in this. So we will make it separately. So here we will be doing the assignment. So when we are making the assignment, we need to remember the rules. So rule number 1 is first we have to go row wise and then column wise. And when we are assigning it row wise, we need to assign only in those rows where single 0 is available. So we can see that in the first row there is a single 0, so we can make the assignment. When we make row wise assignment, so where in whichever cell the assignment is made, that column, if there is any extra zeros, we need to cancel them. So first row there is assignment in the D cell, so D column extra zeros will be cancelled. Now come to the second row, there is no 0 available, so move to the next row. So in the next row we are having a single 0, so we will allot row wise and cancel the zeros column wise. Now come to the fourth row, again 2 zeros are available, we cannot assign any cell here. So now let us move column wise. So column wise we shall see if there is single 0. So in the first column we are having single 0. So when assignment is made column wise, cancellation is done row wise. So here column wise the assignment is made. So if in the same row there are any extra zeros, we need to cancel it. Now the second column is already assigned. Third column we don't have any zeros. So move to the next one. So in the next there is already assignment being made. So now we have done with our assignment task. Now we need to see whether this is an optimal solution. So it will be an optimal solution only if in each of the row and each of the column there is one assignment being made. So in the first row assignment has been done, while in the second row there is no assignment. So this is not an optimal solution. When it is not an optimal solution, we are going to solve it as per Hungarian method by marking the rows and columns. So let us mark the rows and columns. For marking the rows, we need to see in which row there is no assignment being made. So we can see that there is row 2 where there is no assignment being made. So let us mark it. Once this is marked, we need to find in the same row whether 0 is available. So we can see that in this row the 0 is available here. So we shall mark this column. Once this column is marked, see whether assignment has been made in this column. Yes, here the assignment has been made. So mark this row. Now when again the row is being marked, see whether 0 is available. So again it is the same column. So this ends our marking job. Now we need to cancel the rows and columns. So now we shall cancel the rows which are not marked. So row number 3 and 4. Now coming to the column wise, we need to cancel the column which is marked. Yes. So this is how we are going to cancel the rows and columns. Once this is done, we need to prepare our new matrix. To prepare the new matrix, we need to first identify the least element in the open elements. So these are the open elements. Now the least among this, the minimum element among them is 1. So what we will do? We will deduct this minimum element from the open elements, and when there is intersection, so that we can see that we have two intersections, we will add this minimum element to these two cells. Rest values will remain same. So 3 is an open element. 3 minus 1 will be 2. 1 minus 1 will be 0. 4 minus 1 will be 3. 0 kept as it is because it is cancelled. Now next 1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 0 again repeats. Now next 1 is cancelled here. So 1, 0 is also cancelled. So as it is, 2 is also cancelled as it is. Now here we are having the value 1, but it is having an intersection. Okay, so we are going to add here. The minimum element 1 will be added to the element which is here in this cell. So 1 minus 1 will be 2. Next 0, 0, 0. Again there is an intersection. So 0 plus 1 will be 1. So now we are having the new matrix. Again we are going for the row minimization and column minimization like step 1. So now before moving to row minimization and column minimization, we can see that in each row 0 is available and in each column 0 is available. So it means that when we make row minimization or column minimization, our matrix is not going to change. So we can club this into one step. So I will just write row minimization and column minimization. So both we can just show it in one matrix using the same one, because there will be no change. So here in the rows it is 0, even in the second row 0, third row 0, fourth row we are having minimum element as 0. So there will be no change row wise. Same way column wise also we are having 0 in each of the column, hence there will be no change column wise also. So we shall write down the same matrix 2 0 3 0 0 1 2 0 1 0 2 2 0 0 0 1. So the same matrix I have written it here. So that is after row minimization and column minimization we are getting the same matrix. Now let us assign. So the next step will be assignment. So for assignment we will be using this matrix. So I will just write down this 1 0 2 2 0 0 0 1. Now when we are making the assignment, again the same rules. First row wise, any row which is having single 0 we need to assign. So row 1 we have 2 zeros, so no assignment. Row 2 is also having 2 zeros. Come to row 3 we are having single 0, so let us make the assignment. When assignment is done row wise, cancellation of extra zeros will be done column wise. Now come to row 4, again there are 2 zeros. So let us move column wise. So first column we are having 2 zeros. Second column assignment has already been made. Third column we are having a single 0. So when column wise assignment is made, cancellation of the extra zeros will be done row wise. Come to last column, again we are having 2 zeros. Now again repeat the same, come column row wise. So first row we are having single 0. So row wise assignment, so column wise cancellation. Now come to row 2. So we are having single 0, column wise cancellation. So no zeros are left. So we have assigned and extra zeros have been cancelled. So now let us see whether this is an optimal solution. So if to call this as an optimal solution, we need to check whether assignment has been made in each row and each column. So we will just check in row 1 we are having an assignment, row 2, row 3 and row 4. Now see column wise in each column we are having an assignment, then this is our optimal solution. So we have made the assignment of men for their respective with their respective jobs. So let us see what assignment we have made. So 1 is assigned with job D and 2 is assigned with job A. 3 is assigned with job B and 4 is assigned with C. Now let us take their original cost. So original cost has to be taken from the problem given. So this is our real matrix. Now let us see the cost. So here 1 is assigned with D, 1 is assigned with D where the cost is 4, 2 is assigned with A and the cost is 5, 3 is assigned with B and the cost is 7, 4 is assigned with C and we know that row 4 is a dummy column where all the cost is 0. So we will write 0 because there is no fourth men available here. Okay. So let us take the total and this will be our total cost. So total cost here that will be incurred by assigning the jobs to the 3 men here will be 16. Any other assignment will be costing more than this. So this is how we are going to solve an unbalanced assignment problem. So if you like this video, please like, share and subscribe. Thank you.